Hello, hello, hello. All right. I think this is a little bit too loud. Let me turn down my desktop mic just a little bit so it's not completely overwhelming. Okay. So if I check my YouTube account real quick, I should be live. Oh, I don't. I probably don't want to do that. Okay. So hi, hello. I am attempting to live stream. Attempting to live stream my coding. I'm going to be working on my project Chorale tonight. And yeah, let me see if this is actually working real quick. And if so, what kind of resolution we're at. I am decent sort of resolution, it looks like. Yeah, we'll see. Cool. Ooh, ooh, ooh. Let me send a thing to my Discord server. Okay, so I don't know how many people are watching. If you're watching, just I guess give me a shout out in the give me a shout out in the chat, and I'll see it and I'll say hi. But without further ado, let's get started, I guess. I have this Discord server just going in the background. That's gotta be all sorts of fun. Okay, so for those of you that don't know, Chorale is my Notion renderer. Basically, what it does is there is a piece of software called Notion that I use quite a lot. That's basically sort of a text editor, like a super powered text editor, I guess, you know? So for instance here, I was working on writing out some stuff for a paper for one of my classes about religion and health, fun stuff. But it's sort of, I have my workspace set up like a wiki. So what the initial version of Chorale did is it would, if you took one of these pages and you published it, so let me, for instance, share this on the web. This will share all of the subpages as well. If you took that little URL that it generates and chop off this part and just copy this and put it at that right there, put it as a sub part right there. Chorale will just take that and sort of render it out, and it does it pretty decently fast. Not necessarily the fastest for what I want, and it's very, very buggy as well. But yeah, it was cool. I developed it in like a week. It got some attention. There's a really cool spin-off project that uses, it was really, they used some of my typings for it. And so it was really cool getting to see it's a really successful project because it's React based and people like React. But like in here, if you go into the types right here, these are my types, and it's so cool like see them like being used and like extended upon, and that's really, really great. I really I mean honestly, like seeing people use my code was one of my it was such a one surprising experience because I didn't think anyone was going to use this, but two, also like really, really cool feeling because like I wrote something sort of decent for once. So anyway, React Notion, really, really great package. It basically took Chorale and like made a much, much better version of it, a much better performing version of it, and I quite liked it. So what after a while, I discontinued development on Chorale because I didn't want two competing projects that were both basically doing the same thing. So I kind of gave up on it for a minute, took like a 2 or 3 month break on it, and then I started getting really, really, really into Rust because this was happening. This past semester, I tried learning Haskell and Elixir for fun. So I was learning functional programming languages and getting into those and figuring out how they work. And I tried using them for one of my classes, and it did not work very well. But then I heard about Rust, and I heard that Rust had a lot of things that were similar to Haskell and Elm as well, but that it was a systems level programming language, and I got really, really into it. Started learning it, and I was like, hey, what if we took all of my old Chorale code and like rewrote it in Rust? Because like, while React is like very, very performant, JavaScript is not the fastest thing in the world. It's not the most efficient thing in the world. And if all you're needing to do is generate static content, no React dependencies, just straight up HTML pages, you don't really necessarily need React, right? While you can use it and it makes things very, very easy, it's an extra like 110 kilobytes of code that you're only using part of it. So I was like, okay. The other thing is JavaScript code isn't multi-threaded with an asterisk. Some Node code can be, but it's difficult to write if you don't know how to do it. Asynchronous JavaScript tries its best. You get it. So I was like, okay, let's try rewriting my Chorale code in Rust, because Rust is like much more type safe than TypeScript. It complains much more if you get things wrong. I like that much more, right? It's more efficient. It uses so much less memory, and it really forces you to write more beautiful code. So over the summer when I was working a job, I started taking Chorale, or my old version of Chorale, and slowly rewriting it in Rust. You'll see there's quite a lot that's not present, but it does support like nearly all formatting, which is great. And so I started rewriting it in Rust, and it was extremely performant. Let me see if I can actually pull up the code real quick. This is... Okay, give me just a sec. Chorale, right here. Oh, that's an older version of an app that had the same name. I think it's under my Rust folder and Chorale renderer because I had it named a different thing. Yes, that looks about right. Let me see if I can take this and... No, I can't. Okay. I'll just open it from... Oh, I don't need to open... Sorry, there is copyrighted code in there. Well, not necessarily copyrighted, but I can't show it because it's for one of my jobs. So yeah, I started rewriting it in Rust. Rust, as it turns out, is very, very performant, very, very efficient. And Rust has some really nice paradigms that force you to, not necessarily force you, but encourage you to write better code. So I spent a lot of time wrestling with the compiler, and then when I went back and like reread the Rust handbook and like read through it like again and looked at some example Rust code, I was like, oh, I can structure this differently. And so instead of if you look at the initial version of Chorale in this master folder right here. It's very much a mess. So let me see. All of the core rendering code is in this single Notion file right here, and it is all hard coded. I mean, it's only 450 lines of code, you know, so it's not that bad. But it's also not the most efficient, it's not the most well written, it's not the most beautiful, right? There's a few things that it struggles with. So instead, and it's also not a separate package. You can't, I mean, you can use that component elsewhere, but you can't like interface it all together. So I spent some time and really focused on like the design of the library and on building something that I would want to use, you know? Not just something that's easy to use, but something that is like very fun to use. And so what I came up with is, instead of packaging my app into just one giant server thing, putting it in a bunch of like smaller packages, they're called crates in Rust, and doing that. And so I came up with a pretty beautiful solution, if I do say so myself. This is the parser. This is what takes all of the JSON and parses it into very extremely strictly typed structs and enums. So if the JSON doesn't fit it exactly, it will gracefully fall back and not throw an error, or it will just render nothing. There's no errors as far as I know. There's no panicking unless if it's invalid JSON. But this is the renderer right here. It's very for all that it does, it's only 252 lines of code. That's like half of what my previous version was, and this is much more verbose, right? There's a lot of repeated code in here that's all basically sort of doing the same thing, just for a different type. I mean, I could pretty easily use like a macro or something and, you know, cut down on the lines of code, but it's overall just much better looking, and it feels so much better to write in and use. So yeah, it also has a fun functional flavor that I really liked and that you don't get in JavaScript. So for instance, right here, I'm using pattern matching, which is sort of like destructuring in JavaScript, to pull apart a tuple. And then, well, God, it's been 2 months since I've written Rust also. So I'm a little bit rusty, haha. I think this is called shadowing. I'm basically redeclaring a variable that is immutable right here to be mutable, and declaring the, what this is doing is, oh God, I'm not going to describe it just yet. I'll spend some time talking about it later. But anyway, it's much more concise. And what's really cool is you'll notice that it's not like actually outputting any HTML here, right? Like it's not caring about how you it doesn't care which templating system you use. It just asks you to build these 3 different traits, each with different functions on them. And so long as you implement all of these functions, it will take care of rendering out the content very quickly. So that is something I very much like. This base package, it has all the rendering logic inside of it, but not actually how to render that, you know? So over here in the UI package, I created a custom templating library because I didn't really like any of the other solutions that are out there right now. Sorry, I live in a loud apartment. But in this UI package, I basically just implement each of these traits. I have custom, this is just using my rendering language. Where is this root coming from? Root is a tag type. It has been a minute since I've looked at this code. Where is it getting? Oh, okay. This is using a collect function. I don't remember what this all does. I really should have documented this a little bit better. I actually might spend some, that may be what I do today, is just adding proper documentation to it so that anyone that comes along, can work with it. So anyway, I've got really actually well written code here, sort of. This is just a match statement that gets a class name. That's not necessarily the best written, but it works. I can use it functionally. That's all I need. And yeah. So I can completely customize, or anyone that wants to work with this package can just like pick and choose what features they want to use out of it. Like, oh, I want to use the rendering logic, but I want to be able to I want my own custom pothead from the future. Documentation, very important. Yes, documentation is very, very important. So this stream might just be me describing how the package works, aka sort of rediscovering it myself, because it's been a minute since I've looked at it. But yeah, you can pick and choose what pieces you want, sort of like Legos. They're all well built, they're all composable and built to work with each other very well, but also not make too many assumptions. So yeah. It's I haven't counted to see how many lines of code it is just yet, but if I had to guess, it's probably only about 300 to 3,000 to 4,000 lines of code total. It's not a very big package right now, and it does the majority of what Chorale could do, besides just some generic server-side rendering stuff. It doesn't do page links also. I need to figure out a better way to do that, because that's a little bit more difficult, but it does the majority of them. So yeah. All right. So, I guess this is just a good time to, if you're a beginner in Rust, to, I guess, just watch along with me as I'm reading Rust code that, while I did write it, I don't really remember exactly how it works. So this is a good time for me just to explain things, document things as I go, and yeah, read through some code. So, okay, let's get started. Let's start documenting. I'm gonna start by folding all the code real quick, just to make it a little bit less overwhelming. That way we can work on documenting just one piece of code at a time. Let me look up Rust documentation comments, because I've been working in C# and I don't remember how Rust does documentation comments. Okay, cool. Implement this trait. A trait that when, okay, so the block renderer, it is when you, this might not be the best place to start actually. It might be better to go through some of the rendering code and then reference this up here as needed. So yeah, let's go through this renderer, describe how it works, and then go back up here and document some of this. So this renderer is a strut. It is published, which means it can be accessible outside of this this file in the crate. However, each of the items on here, specifically this blocked piece, block renderer, inline renderer, wrapper renderer, and P, which is phantom data. I'm not exactly sure what I'm using that for. If but I'm using some weird STD markers. Okay. They're each, imagine them like private members on a class if you're coming from Java or something like that. Basically what you're doing, basically, if I were to write this in C#, I've been working in C# for the past 2 months or 3 months or so, no longer though. These would all be private variables on this, and this struct will sort of build a constructor for you. You can write. You can create a new struct in the same way you can create like new classes in C#. Okay, so each of these things in here are, I think, either called templates or generics. They're called different things in different languages. Regardless, basically what they are is like placeholders for a type. That way it is abstracted. Specifically what each of these are doing, this is a lifetime. I'll explain that in a second. This R is describing the type of the templating thing, right? We need to know that in order. Let me check. The type of the object that's going to be returned by each of these like block renderers, whatever the return type is. They all three have to be the same. There's various reasons as to why, just to, you know, promote type consistency. Then each of these other ones right here are, I guess, just shorthands for referencing this R type. They're using each of these 3 traits up here. And so, yeah, that's what that means. This lifetime, there is a very, very good video on lifetimes. I forget by who. You should be able to just search for Crust of Rust. Crust of Rust is a really, really good YouTube series by someone whose name is slipping my mind right now. Check out his stuff on that. Basically, it's me helping the compiler along to tell it, oh, I'm just borrowing this. I don't want to actually own this. I do want to own this block renderer, inline renderer, and wrapper renderer. We don't want that to be reused. I'm a little confused what I'm doing with this. Oh, this P is the sort of like accumulator, right? How this works is it will sort of start at the lowest level of the I guess the block tree. It'll start rendering out those root nodes and then combining them, and then it'll stick after each iteration. It'll stick that in this P node right here. Okay, cool. So that's all this means. This is just declaring what data we want in this struct. Then we get into this impl block. This is basically just a separate way of implementing methods for a struct. Think of it like writing methods on a class or something. We're repeating a lot of the same stuff as up here. This right here, we're just bringing these same templates in scope of this impl block and then passing it into this renderer right here. And yeah, then we get into all of this mess. So let's go ahead first and document this renderer. Let's say the main Chorale renderer stores has a variety of methods and private variables. This takes care of all of the Notion rendering logic, e.g. Let's bring this down a line. E.g. Parsing the Notion JSON. parsing the notion JSON, iterating over the JSON and building out the results that will be returned. This piece of code is not responsible for actually implementing the templates that will be the templating logic. That is instead it calls methods on 3 different structs: block renderer, inline I should really do this. Block renderer, inline renderer, and wrapper renderer. 3 different structs that have the traits block renderer and inline renderer. By calling these in specific orders, it is able to return a result without needing to ever manipulate the result directly, just by calling functions to do so. Okay, cool. So there we have it. So that is the documentation for this struct. That is what will show up. Let's add on a little bit of documentation. The renderer has ownership of all 3 structs that are passed in using the new method, but does not own the block table type that may or may not be passed in at different points. This allows the user to reuse templating object is explicitly tied to the renderer instance, but content, but it is reusable, meaning you can declare a single renderer and reuse it for multiple different strings or different unparsed JSON or strings. Parsed JSON or strings. This renderer uses the definitions provided by the I think this is just me writing documentation. It uses the definitions provided by the parser module, which declares a number of JSON. Shoot, I forgot. Certa, which declares a number of Certa JSON typings of strict Certa JSON typings with smart fallbacks. The renderer takes the same with graceful fallbacks. The renderer takes the same approach gracefully falling back if it encounters JSON that doesn't necessarily understand if part of the JSON doesn't make sense to it. It will, if a block is invalid according to the latest version of its latest versions of its typings, it will skip rendering that block and all of its children. Okay, cool. So I think that's properly documented. I'm confused as to, okay. Let's document each of these individual properties, because you can do that in Rust doc. Rust doc is what I'm writing right now. It's pretty great. Highly recommend. It's important to stay hydrated, kids. Okay. So this right here, this blocks variable is just a caching value to make passing down the blocks a lot easier. Caching a value that property that caches the block table, making it easier and slightly more efficient making it easier to pass down the maybe I should zoom in on this just a little bit. There we go. Oh, that's much more visible. Property that caches the block table data, making it easier to pass down, across multiple during recursion. We'll just say that. Okay, the block renderer. Templating definition for rendering blocks with the trait type of block renderer. This is a templating definition for rendering inline markup with the trait of inline renderer. And then this wrapper renderer. Wrapper on elements like bulleted lists or let's say bulleted lists, and I can't remember what else I use this wrapper renderer for. Bulleted lists or numbered lists. Blocks like bulleted lists or numbered lists need to be rendered inside of a UL tag grouped together. The wrapper renderer takes care of this logic. Okay, that I'll just repeat up there. Yeah. This right here is an accumulator value that represents a placeholder value. No, it's an accumulator value. Value where the, I think that's what it's used for. Let me, where is this used? I don't know if this is used for anything. Why am I using phantom data? I feel like that's a compile time error that I just wrote some really shitty code to get around. What is phantom data? In Rust, okay. Phantom data are related but not identical. A phantom type parameter is simply a type parameter which is never used. And a solution is to add a dummy use by way of phantom data. Unused lifetime parameters. I think this was. I think I can get rid of this actually. Let's try commenting this out and see if this causes the compiler to complain. Let me cd into this testing directory and run progress build real quick. I hope it doesn't complain. Unused type parameter. Why am I writing things this way? Does it complain if I, okay, it's related to that R. I feel like I tried to do something with this, but it did not work. Whoops. Okay, change that. Then we change that and just pass down R. Let's try compiling this. I feel like that should work. Okay, doesn't have a size known at compile time. Help, use dyn. Trait objects without an explicit dyn. Oh yeah, there was a reason for me using that. Man, this is such a weird, okay. Okay, so it looks like this doesn't have a size known at compile time. I think if I make this a reference though, and then just add the same lifetime right here, that should fix it. I have a feeling some random Rust person is gonna come on and be like, no, that's not how you do it. What is trait objects without an explicit dyn are deprecated. Use, okay. What does a dyn do? Dyn Rust. It's been a minute. Dyn trait for trait objects is a new syntax for using trait objects in short. Box trait becomes box dyn trait. Trait and mute trait become at dyn trait and at mute dyn trait. What about a oh wait, maybe we should do this as a box. That would make sense. Just that's a type safe pointer. Well, yeah, yeah. Just these aren't accessing the same value. No, well, that should work. I shouldn't need a reference in here, should I? Or a lifetime. Eee. Oh, no, no, no. Put a box back in there. I'm determined to figure this out. Okay, help use dyn. Oh yeah, I forgot I have to add that on there. If I can clean this up, that'd actually be pretty good. I don't know why I'm not using my caps lock like I normally do. Just I almost always map my caps lock to, okay. Cannot find type B in the scope. Do I have the Rust analyzer installed? I don't know if I do. I do have Rust analyzer installed. I don't know why it's not pulling up errors. I'm guessing probably because I have code folded, but oh well, it is what it is. We have to remove this. So this was an error. So I wrote some pretty bad code. Instead of borrowing these, I wanted to own these for whatever reason, and it honestly makes more sense to just borrow them. Let me just try be dyn. I feel like that's gonna get me into trouble. I feel like there's gonna be some multi-threading stuff later on that's going to fuck me over on that. Okay, let's see if it complains. Okay, so no complaining yet. So, okay. We should just be able to say here and B, and this is a dyn. Just using the trait name, the current syntax is often ambiguous and confusing, even for veterans, and favors a feature that is not more frequently used than its alternatives, is sometimes slower, and often cannot be used when its alternatives can. Furthermore, okay, alternatives to trait objects, Rust. Is it really considered bad form to use box with traits? It is not bad, you just need to be aware of what the trade-offs are. What's bad are people using box trait to try and write C# Java code in Rust. It's a tool, not a cudgel. I feel like it ought to be more commonly than it isn't. For an example of okay. Okay. This is something I was not aware of. What's the difference between impl trait and dyn trait? Okay. This may require a lot of rewriting. Oh no. Who chooses the return type? The caller or the callee? The caller chooses, okay, T is an iterator, the concrete return type. For example, they can be explicit and call something like this. Cannot choose the return type and doesn't even know what the concrete type is. They only know it implements iterator. For example, the caller might do let fun equals something, and you can see it's impossible to choose the return type. Okay, not that I'm aware of. This term's from type theory and is covered. It's a union type, including all the values of its type parameters. Each value of such is blank. Okay, so can we do impl type? B, box versus reference. I need to see that. Box is a library to find smart pointer. Ref is a syntax for pattern matching. It's a reference operator, doubling as a sigil, and doubling as a sigil in raw pointer types. I remember reading this. What's the difference between a box and this? Boxes can also be borrowed. Can be borrowed. You can get an @t out of a box. This can happen with the dot operator, or you can do it explicitly. Similar to built-in pointers, you can dereference operator reach their contents. This is possible because Rust is overloadable. And finally, ref. Okay, why is it a smart pointer? This is not. Raw pointers which don't have restrictions of references should be used in low-level code implementing blank. On size types, these types do not have a statically known size and therefore can only be used through a pointer reference. However, only a pointer is not enough. Additional information is needed. For example, length for slices, or a pointer to a virtual methods table for trade objects. The information is embedded in pointers. Blah, blah, blah. I can't read that. Okay, so basically use this. We shouldn't be using a box. Okay, so we have to, well, impl. Let's use impl. Rust, except in structs that uses trait. Missing lifetime specifier. I feel like I usually end up going down this route quite a lot. With the bare question, what's the implication of removing? Okay, no, that's not what I'm looking for. Using any struct that implements a trait in another struct. Do it just like this. Okay, basically I was doing it right. Rust was complaining about it for some stupid reason. I should have just kept things like they were, because doing it with that box-dyn syntax is stupid, and yeah. Okay. So this is just a phantom value. To get the compiler to shut up about a, well, if I remove this real quick, what does the compiler say? It says unused parameter. Okay, about an unused parameter. Okay, cool. So my extremely minor performance cost. I don't particularly care. So let me look real quick at how this is being actually used in my testing library right here. So we create a new renderer. It has a type. And then we pass in these structs. Okay. This is old. Don't put trait boundaries directly on a struct when it is avoidable, because such bounds are forced to appear all over the code. Instead, put it on the functions or impls which require that trait. That would be all of them. I'm fine with repeating those, because I don't repeat them a lot particularly. Put a bound on the struct itself. Oh, okay. So what they're saying is keep this generic and then have... Okay, yeah, that makes sense. That way, if I need to, I can declare multiple variations of these. Okay, that's very, very smart. So B, I, and W, sorry. B, I, W. So it turns out I shouldn't need this, I don't think. No, I don't think I need this. Okay, that's nice. Where, oh God. Where B is a block renderer of type R, I is a, oh wait. Where generic rust impl where clause rust by example. I just need the format. Okay, cool. Where B is a block renderer, I is, well, I don't know what the Rust code looks like. B is a block, well, real quick. Inline renderer of R, and W is a wrapper renderer of R. Okay. I feel like that's hopefully going to be a little more pretty. It's going to complain. Wrapper render. Cannot find type R in the scope. Okay, we should be able to comment this out safely. Okay. Unconstrained type parameter. We don't need this R, which is awesome. Wait, impl R has not been constrained by an impl trait, self-type, or predicate due to previous error. Ooh. Unconstrained. Okay. Unconstrained impl type. Impl dummy. Try adding a generic parameter to dummy. Turns out this works and doesn't error for some reason. Okay, so it is still useful having this R value in there even though we need it. Okay, add that back in there and then we can pass back in this R. Okay, turns out we still do need it. Whoa, that's an issue. Oh, I feel like this is due to me running on the beta. Linking with CC failed. Exit code 1. Okay, let's find this out. Error. Linking with CC code. Exit 1 only appeared. Simplest application. Looks like this is still happening after 2 years. Yep. Sudo gcc multilib is what it looks like. open because it's still happening. This is fixed with sudo ch own -r user whoops. Okay. Sudo chown r user dot slash Sam, a legal group name. Cargo clean, and then cargo. We'll just run build real quick and see if we can get that to build. One thing I hate about, only thing I don't like about Rust is it takes absolutely forever to compile, especially right now when I am attempting to stream a 4K monitor. So that can't be the fastest thing for it. Yeah, this is there we go. It is very, very slow. Not normally this slow. It is usually much faster. But it's slower than like something like C# or C, you know, or I mean obviously Go, because it's a regular language. So yeah, it's a good time to stop and eat. I'm hungry slightly. That's also quite a lot of crates just for one crate. I might see later on if I can. I think a lot of these I'm not actually using. Some of them are like my API package uses Tokyo because I want it. Well, I need it to be async, but I don't. Sorry, no, my testing package uses Tokyo. The API package does not use Tokyo. It just defines some stuff. Anyway, it might be worth it to see if there's. I hope that there's like a good thread pooled alternative, sort of like the Elixir thread model. I think is really, really, really good. I wish we had something like that in Rust. Okay, there we go. An optimized build. Okay, let's do a cargo run. Should work. Normally this is much faster, but it is what it is. I think I had to pull content. Oh yeah, there we go. Ooh, these grapes are good. So this generates an output.html, which has a lot of content in it. If almost all my CPU were not being used by OBS right now, it would run much faster, very, very fast. And on a server, it's probably going to run extremely quickly. I don't want that door staying open. Okay. So changing that worked. That's good. We cleaned up the code pretty considerably. This means if there's a different alternative and we need to write different rendering code for this, we can just rewrite it. Like if people want to use different traits or something, or an updated trait, I can keep backwards compatibility very, very easily. And yeah. Hmm. Ooh, yes, actually. That's going to be very, very great later on. I could version these traits. So upgrading is incredibly easy. Hmm. No, let's not actually. Okay. There we go. So we cleaned that up quite a bit, quite considerably. That way it's not a huge piece of junk right here. And it's only being repeated right here. I don't completely understand how that works, but it works, I guess. Okay. So next we're going to, I don't really think there's anything to document on here. So, yeah. Let's document this real quick. This creates a new renderer. Requires the 3 traits. It requires 3 Where's this block table type coming from? I don't think this is, oh, okay. Oh, that makes sense. Well, okay, so this is explicitly for if we want to, okay, I'm gonna have to change my documentation. We pass in the blocks, and then down here in the renderer, we pass in the block ID to render. That way, we can do more. Okay, that makes sense. I mean, it's not the most, it means this renderer can't really be reused. But I guess it does help with, I think that's a valid choice. I'm gonna keep that for right now. Okay, so I've got to change some of this documentation up here. That may or may not be used. All 3 structs in the blocked table. Different points. Templating logic is explicitly, but it is, no, this is not reusable. But it's reusable, meaning you can declare a single renderer and to render multiple IDs on a single block table. Tied to templating logic, and the block table are explicitly tied to the render instance, but the render is reusable. Okay, cool. So let's go down here, and it creates new render, requires a block table, parsed. Sorry. Well, is there a way for me to, I really wish, oh my god. Wow, these grapes are deflated a bit, I guess. Well, they're just soggy. I really like grapes. Okay. So I get why I did this. There's a few reasons. The main one is, if something better than like Serde JSON comes along, right? I don't want people to be necessarily required to use it. However, this block table type is explicitly tied to Serde. So it may be better for me to rewrite this for it to just be a string, you know, for this to handle all the parsing. I might add a to-do in here to do that. Okay. So this requires a block table. We'll say the parsed Notion JSON document. Only the blocks. A block renderer struct that implements the block renderer trait for some R, an inline renderer struct that implements the inline renderer trait for some R, and a wrapper renderer that implements the wrapper renderer trait for some R. Returns a renderer that can then be used to render individual IDs or blocks and their children on that block table. Okay, cool. So yeah. I don't know if this interface is specifically the most elegant way to do that. To do in here, change blocks string and handle all of the parsing. Okay, cool. Awesome, awesome. All right, so this is all documented right here. Ooh. Kind of want to see Rust doc. Okay. Missing file operand. Okay. Okay. Looks like we're having some Rust doc errors. Whoops. I really should be spending time like actually you know, writing, finishing Chorale to actually work, but documentation actually is very, very important. Okay. Okay. Whoops. Oh. Okay. that's the issue. I'm done. So Rust stock was missing a scope. Couldn't find it, so we're using it with cargo now, and that should fix things quite a bit. Okie dokie. Okay. Okay. CD target, that's copyrighted. Rip. Oh, okay. That's very idiomatic. I don't know what that means, but okay, it is what it is. So yeah, here's another thing I love about Rust. It's that these documentation comments get transformed into this really, really beautiful and very, very useful documentation. And yeah, we get to wow, yeah, this is actually really, really cool. So yeah. Yeah, the Rust documentation comments just get transformed into all this of a sudden, which is very cool. The other thing which I guess kinda sucks. I want to write examples for this, but I'm not going to be able to write one, but that's okay. Okay. This is the renderer is not responsible for implementing sampling logic. Instead, it calls method on 3 different structs that have the traits block render, inline render, and wrapper render. By calling, it is able to return a result without needing to ever manipulate the result directly, just by calling functions to do so. All 3 structs in the block table that are passed in using the new method, but does not own the block table type that may or may not be passed in at different points. Templating logic and the block table logic are explicitly tied to the render instance, but render is reusable. The renderer, but whoops. Okay. The renderer uses the definitions provided by the parsing module, which declares a number of strict asserted JSON typings fallbacks. The renderer takes the same approach, gracefully falling back if it encounters JSON that it doesn't necessarily understand. If a block is invalid according to the latest version of its typings, it will skip rendering that block and all of its children. Okay, this is really cool so far. Okay, it skipped my to-do stuff. That's really, really great. And it just sort of put these methods in. So now we just have to document these methods and then we're good. I'm gonna also document these private methods just because it's good to have that documentation. So for instance, right here, we can say this is a helper function for determining a specific root block type needs grouping or not. This should probably not be defined on the renderer, but it is what it is. To do here, move this to the parser module. Okay. So what is this doing? This function determines if a given root block type value can be grouped with the other base value type found in the grouping accumulation vector. I'm confused as to why I'm not reusing that here, but okay, it is what it is. This only compares the type against first item in the vector. It is assumed that only items that are allowed to be added to the vector are items of the same block type. Therefore, we only need to check single value instead of checking all values in the array, the vector. Okay, cool. There might be some other opportunities to speed this up, but I'm happy with that so far. That does need to be rewritten. To do rewrite the checking logic to use needs grouping. Okay, render wrapper. This function renders. Okay, we can probably just use. We probably don't have to use the word this function. We can use that there. I'm fine with that there. I'm trying to make this really, really good documentation so that anyone that comes on the product or on to work on this knows what I was doing, sort of. That also means I'm gonna have to go through and change some of these variables, which is not gonna be particularly great, but oh well. Renders a wrapper. Do we perform a check in here? Okay. A wrapper around the items in the accumulation vector. If the vector is empty, returns an empty item, else returns a okay, cool. I should probably add on an arguments thing to this. So like right here, I can do arguments, value, value, okay, cool. This documentation is fine for me. Returns the wrapped elements. And in here, we'll document these. Vector, the vector of items to wrap. Okay, cool. I think that's well documented enough. I think we've increased this by quite a lot, but that's okay. Render children. Okay. Why am I calling this twice? If self and can be grouped. Grouping result dot. Yeah, or b dot length equals 0. Okay, this is going to require some additional documentation because I don't know exactly what I was thinking when I wrote that. And it's not really obvious what I was doing. Renders an array of children IDs. Children. The collect method on wrapper, the user defined wrapper render to collect all of the items after rendering them each. Okay. Let's do this. Renders an array of IDs. Takes care of calls render for each, wrapping them if necessary. Uses the collect method on the user to collect all the items after rendering them each. Okay. Arguments. IDs. A string array of IDs to render. If the ID is not found, after rendering them each. Okay. Let results equal iter.fold. What happens if rendered equals self dot render at x. How am I? Where am I getting x? X is a really shitty name for a variable. I have to rename this. I'm not sure if a tuple was the right decision for this actually. Well, yeah, so long as it's named correctly. Okay, so this is the ID. Okay. If an ID is not found, this method what happens if our ID is not found? This method, it will not be rendered, not found in the block table. It will not be rendered. The collect method on the wrapper renderer should handle cases where there are no elements. E.g. simply calling empty an empty method on the block render. Okay, so I should add on a to-do here. If the resulting array, array is empty, don't call collect, instead call empty on the block renderer. Okay, cool. Oh wait, this needs to be like that. Okay, awesome. I think that's decent documentation. Okay, let's look at what each of these is doing and try to change some of these variable names because it's not immediately obvious what this is doing. So for instance, this variable x should probably be renamed, well, I have to do that. F6. How do I rename a variable? Okay. This should be ID. I think for whatever reason, my Rust thing is just not wanting to work. So it looks like we will just be building intermittently to check to make sure this works. Or while doing a cargo check, sorry. Okay. A better variable name would be block ID instead of ID. So let's call this block ID. And then what is this A? This A is the first. Okay, that looks like that's all where it's used. Let me see if that's a word. Okay, yeah. Okay. We have a, let's document this, defines an accumulator variable that is a tuple. The first item is an array of rendered items, completely rendered items, and the first item in the tuple is an array of completely rendered items. And the second item is an array of, is an accumulator array, is a temporary accumulator array for grouping. That's the only downside of using tuples like this, is as far as is there a way to name? Is there a way to name a tuple? No, it would look like that's not possible. Actually, we could define a struct inside here and then destruct, or no, an enum, I think. Yeah. It'd be a little bit uglier, but it's possible. Let's rename these variables first, and then I think we can define this as an enum so that we don't have to rewrite, like, document all these comments, or add all these comments in here for documentation. So we pass in our accumulator. This makes sense. Results. Is there a better? We could just reshadow this accumulator because it's not the results, you know. Okay, sum block equals the element. So we're checking to see. There's one of those. If either. Oh, that's right. I'm using a custom either thing, which is pretty dumb. Wow, I've been coding for an hour and a half. Okay, this mute A is the rendered items. And this is the grouping accumulator. Items needing grouping. Okay, that makes sense to me. So actually that's pretty long. Okay, that works for me. Return a lot of these results. That might be better. Okay. So a push. Haha, that's giving me bad flashbacks. Okay, so this is more verbose. It's not as beautiful as it was before, but this is not intended. It gives a little bit more context as to what's going on. So this B thing, items needing grouping. Rendered grouping. Let's just call this needs grouping for right now. And we'll say needs grouping. We can change all these. Yeah, that looks much better. Okay, rendered items. Rendered, and then this needs to be needs grouping. We can debate names later. This is better than what it was. OB is needs grouping. Okay. Okay, results is not found in this scope. That is because this is the accumulator. Okay. This will get much better. Once I finish this. Okay, there we go. Oh, right here we need to return rendered items. And then rendered. Okay, cool. So let's try running this, see what we get. Cannot find on 192. Okay. This is needs grouping. Cannot find value B in the scope on 196. Sorry. Yeah, we use the word result too much. Rendered items, rendered item, probably not the best stuff, but yeah. On 207, rendered items needs grouping. Okay, and this should be complete. Okay, cool. Another thing I really like about Rust is all the type safety you get from that. So you saw how many names I missed there. That was not particularly pretty. So yeah. In any other language, I probably would have missed that, but yeah. Okay, cargo FMT. There we go. That looks much more beautiful. Oh Christ. Fold. Okay, I'm not really comfortable with how this looks particularly. Let's add some spacing in here to get this looking a little bit better. That looks good. I don't like these statements right here. If this block needs grouping, that definitely does not. And it can be grouped, and we have an item available there. Then we have one condition. See, this just doesn't look very pretty to me. Rendered items dot push. So for instance, right here, this we're having an extra allocation for something that could be done like this. A little bit. It's not as beautiful, but it reduces the number of lines and the clutter, really. So for instance here. I'm also using this code repeatedly right there. Where is this result coming from? Either left result, let's call this block value. Yeah, this makes a little bit more sense. Because result is not really. Well, we'll call it block value. I'm a Rubyist, if you can't tell. Okay, this makes much more sense. I really need to get rid of the word result in here. Okay. Block value, how else can we clean this up? We have self.needs grouping. If our needs grouping.length is greater than that, else we're going to render items push. It looks like we do so we push this right here. This makes sense. This does make sense. Needs grouping dot push, rendered items dot push, needs grouping. Why are we running the, oh, okay. Let's see if we can define a variable for this. That way we don't have to write stuff. Needs grouping dot push block. What's a word for this? The main thing that's ugly about this to me is just this 3-line thing right here. If I can move that up here and have it be a bool and then just reference that right here, that cleans that code up, because this needs an explanation. This is explanatory. If our block needs grouping, we do this. It's if it needs grouping can be grouped and our group has stuff. Block can be grouped. And then we can say our self.needs grouping at block value.block, and then add on and self.can be grouped, and block value.block needs grouping, and then here add or needs grouping.len equals 0. And if I find that we're reusing this anywhere, we will just copy and paste it. Actually, this would be much better done like this. No, let's undo that real quick. Oh, by the way, stream, I don't know if anyone's listening to this. Christ. Okay. love that Rust does not require parentheses for something like that. Okay, so now we can just say if block can be grouped. Okay, that is much simpler, much more beautiful. I wish it had more space right here because this gets kind of, you know, choice. But that does explain a lot. Okay, let's call this needs grouping. Let's call it let's call it grouping Q. That makes much more sense. Okay, there we go. Because it is a Q. No, it's not a Q. Grouping set. There we go. That's the better name for it. It's not a Q, it is a set. Okay, and so we can change this needs grouping to grouping set, and then add that here. I don't know why I can't just change the name, but apparently I have to go through and do each of these myself, which sucks, but it is what it is. Okay, that is a much better name. And then I think I would consider this properly documented. Okay. Let's run a cargo check and make sure we got all of them. We did not. I think I actually changed something. Whoops. This right here got changed. Okay. Awesome. There we go. So I still don't like how this looks. For instance, this if condition right here should let me move this to the left. Oh yeah, okay, so for instance we can probably add on let either left block value equals and block dot value, so we can get rid of a level of indentation in here, and that becomes much simpler. And so cargo FMT real quick. That should, well, cargo build check. It's gonna give me errors. Let expressions are not supported here. Okay, Rust to let. Is there a better way to do this? Okay, so that's limited by the syntax of the language. We can't do that apparently. Yeah, so let's run cargo FMT real quick. That should clean things up quite a bit, and there we go. We have some beautiful-ish Rust code, I guess. This is much more explanatory. Grouping set makes much more sense, and then this rendered items makes much more sense. So, and then we have a comment up here explaining how this accumulator works. This fold, right, let's add a reason for shadowing, shadow, I think that's what it's called, rust shadowing. Yeah, that's it. Shadowing the variable here, so as not to add another confusing name. It's still an accumulator. This would be a good candidate to replace with an, you know, that has more self-explanatory. Okay, cool. This also might be able to be simplified a bit right here. So for instance, push rendered. I don't know vet.push. What does it return? It doesn't return anything, it can't be changed. That sucks, but that's okay, I guess. Has more self-explanatory names. Okay. I think this piece of code looks much better. I think that's properly documented for me. Oh Lord. Okay, now we get into rendering the text. This is where some of my, oh, for instance, these IDs right here. Let's call these block IDs because they're explicitly supposed to be block IDs. When I say this is some of the most beautiful code I've written, this is some of the most beautiful code I've written. Okay, and then we have block ID right there. That makes sense. So long as you're reading carefully, that shouldn't be too big of an issue. Okay. This is all properly documented so far. I might want to give this the same treatment. This is fairly self-explanatory. It's obvious what's going on there. But something like here, it could really use it. So like for instance here, we could call this rendered items, like that. Okay, just like that. We're collecting these just into a vector. This vector should really be called a grouping set. Okay, we are calling the empty renderer, which is good. Why are we calling this first? First block value. Oh, that makes sense. Okay, we're holding on to that, rendering all of our stuff out, and then returning our first block value. That makes sense to me. Okay. The grouping set. Vector of base value types. really, really hot inside this room, and I don't know why particularly. Okay. First block value, wrap render, empty. These are all self-explanatory. Good. That code looks good to me. Now we have render text, and then we have this gigantic render method. I really hate how indented Rust code can get sometimes. I really wish there were a better way to do like these. Well, there is a better way to do a lot of these closures, but I don't know if I necessarily like it. So I might delve into this a little bit further and see if I can simplify it more, but yeah. I have one comment in this entire file before I edited it. Okay. This now brings us on to the render text function, which I believe, from the looks of it, is used to render inline formatting. Okay. Renders renders text, formatted text, cursively, iteratively rendering the wrapping it with the appropriate inline styles. Inline styles can either be context styles or no context styles. No context styles don't require any other information other than the type of the inline style. Context inline styles, however, require some other piece of context to render them, e.g. A link requires an href attribute. Different methods on the inline renderer, passed in the renderer, are called based on this with different numbers of attributes. Ooh boy, this is really, really bad. Okay. Text.iter. Okay, so cleaning this up, I'm a very, very big fan of explanatory variable names that get rid of extra comments. So cleaning this up, first things first, scanning this, it's not immediately obvious what this does if you don't know what the block render empty method does. So what we're doing is we're initializing it with an empty block, an empty rendered block. So let's call this empty initial value equals self.block renderer dot empty. So we're calling that. That's an extra. I mean, I think the compiler should optimize that, but it is what it is. I guess this ack is good. This is current value. Okay, this is current text, and so yeah. I have to go through and change all of this X stuff to Y. This function iterates over all of the rendered text, then runs the collect method to concatenate the resulting array of our values into a single R value. Okay, cool. Okay, let initial empty value equal this, not current text. Oh yeah, current text dot formatting dot text formatting. This makes sense. Initial, let's call this base text. And then we'll pass this in. Well, not do that. We'll pass this in here. Whoops. Okay. We'll save that real quick. And I think VS Code just crashed. Well, we'll reload it real quick. Okay. So we have current text right here. I may just have to, there we go. So we have initial text equals this, and then that. Okay. So there we go. Awesome. So I'm just providing some context as to like which ACK this is. So this is formatting ACK. I don't know why we have this value F, no context, match F. This is a format type. Right there. This would be the same. Format type. Okay. And then this resulting value, we need a better name for this. Oh, wait, why? Current format. There we go. Okay. Initial text wrapped formatted text. We can use that long name because we're really only using it down here. And there we go. We just declare a new value, a new array with our at, and we're calling collect on here quite a lot, and I don't know if I particularly like that. I'm not going to change that right now, but to do, let's add a to do one here. Change also, it's not instantly obvious to me that we're returning this text by iterating over it. I mean, that's a prettier way to do it, to just join it, I guess, but it would be more performant if we just collected this instead of folding it. Change, so text.iter.map, or to fold, to use text.iter.map and collect at the end only once. Okay, cool. This is now properly documented, in my opinion. Oh, link format. This is the href, right? And then this is the color, highlight color. I know we're just passing that in there, but that's valuable information. Okay, so now this is properly documented. Let's run cardo doc real quick and see what we have now. Okay. Oh wait, I should have the Finder window still open. So let's view this all thing right here. Okay, this is much more of, this is much more what I expect of Rust documentation. We have blanket implementations of stuff, auto trait implementations. We have a few things right here. We have everything documented except for that. Okay. This is starting to look much more like a crate that I would actually want to use instead of something that like, oh, that's cool to look at, you know? Overdone documentation is not necessarily a bad thing. The less I have to read your code, the better. I would prefer to read a big page like this that's well written. This isn't necessarily the most well written. But a larger page that, you know, has all of the information instead of just, you know, a few. Is it possible to do rustdoc on arguments? If so, that might be very useful. Okay, I gotta put straight chat real quick. I'll be right back. Okay. So continue a little bit more. I might skip like actually cleaning up this main renderer function and like renaming variables and stuff. Oh my god, look at that source. That looks so much more beautiful. Fewer comments in there. This does need to be cleaned up so it's clear what we're doing. But this is actually very, very pretty. I quite like it. This render children function though. Look at that. Comment is used as a justification or an not as an explanation for the variable name, right? Justifying renaming this to, or keeping this named as an accumulator. And then we go down here, rendered items, grouping set, push to our rendered items, and then wrapper.collect, rendered items. Collect is a good name. Okay. That is gorgeous code. I love that quite a lot. Okay. There you go. Okay. So if you ever need to, you can go in here. It's well-written code. So it is easily, I mean, you can look through this and debug it. It's not particularly long. It doesn't have comments everywhere where they're not needed. You know, this is just an explanation of a tuple type. I can replace it with an enum, which would explain it. It is gorgeous. I really, really like this. We can show a declaration, fields emitted. We can go in here and view the source. We have comments here. Doing each of those. Gorgeous, man. I really, really, really love Rust documentation. It is beautiful. Okay, so now on to this main render method. It's actually not that bad. I think I wrote most of this correctly. I mean, for things like this X value, it's pretty obvious what it is. I mean, we could change it to property, but that would just add on a lot. It's just being used as a, like, immediately afterwards on the same line. So I don't think that's a big thing. It's not clear to me what this temp thing is being used for. Why are we using an unwrap or? Content. So where's this temp being referenced? Right here. So this is a vector array of strings. Oh, default child IDs. Okay, that makes sense. Okay, that's what we're using it for. It's not a temp value. You never have a temp value. So this value right here is a block value. Let's avoid shadowing. Unless if absolutely necessary, because this is not the same thing. And then this value right here, multiple of these, okay. Value.content. Why am I, can't I just do, I don't know why that wouldn't work. That should all work. And x.text 265, what did I do? Render text. Oh, X would be, what is it exactly? Current text, sorry. Okay, there we go. Yeah. Oh shoot, give me just a sec. Current text dot text. Let me close that. Let me try. Yeah, okay. So got rid of a value that we don't need. That simplifies it quite a bit. And then this right here we can change to a block value. Okay, change value right here. That needs some space, and then that needs some space. Just this is a different thing right there. Okay, let's run a quick check. Make sure we got all that. Probably didn't. Nope, we did. Children. Where's this used? It's used everywhere. Let us keep that as is for right now. I don't know if adding rendered children would make sense here. So yeah. This root right here can also be root block. Well, we can do self.blocks.get ID like that, and then say root block. There we go. Go check on it. There we go. Okay, let's add proper documentation. For instance, let's change this to block ID. Let's do that. Okay. Oh, render text does not have an arguments thing on it, which it does need. Arguments. Let's add on an empty line. And right here. Or text. A vector of formatted text to render. And have 0 items if necessary. Okay, cool. There we go. Let's go in and add in a comment in here. I don't know why I'm doing as ref right here. That might be something I can fix. I will see in a minute what's going on there. Renders a block given the block ID. If the block does not exist, renders the block's children if it has any by calling render children. Render children. Renders the other shit. If the block is empty and has no, renders the block, whoops. If the block is empty, calls the empty method on the renders block render. This method solely calls methods on the block render based on the block's type, passing in the appropriate render. Okay. Arguments. Block ID. The ID of the block to render. If the block is empty or does exist, calls the empty method. Okay. Man, I can hyper focus on this shit for hours. Whoops, that needs a triple comment. This method solely calls methods on the block render based on the block's type, passing in the appropriate methods to each method. Passing in the appropriate methods, it returns a single arg, whatever the templating value is. Okay. I don't really think there's that much else to this. I think the more complex logic is actually up here and really in the parser. I think the JSON parser on this is probably the most underrated part of this, because that took, I mean, look at it. This took forever, and it's going to take forever to document as well, but it does sorely need it. You know, having properly documented versions of these would be great. Okay. Overall, very, very happy with the progress made today. This was a 2.5 hour stream, and I did a ton of work and facelifting on this file. Yeah, I really, really, really want, sorry, cargo doc. I really want the documentation on this to be something special. I want it to, like, sparkle, you know? I want it to be beautiful. Oh, look at that. Look at that. That is proper documentation if I've ever seen it. That's a little confusing to me, but it is what it is. For arguments, it would be great to add examples in here later, but that's going to require, like, quite a lot of testing. Yeah, man. This looks, I'm not sure where it's getting each of these right here. Auto trait, ref, unwind safe. Unwind safe, okay. I don't know why these auto trait implementations are on there. Those, I guess, might have just gotten added. But yeah, the renderer is now documented. That is beautiful. I just have to, oh Christ. All of these parser types. Ooh. Enums. Parser. It might be good to split the parser out into a separate package. Not really. Parser from color. Oh, that's an internal type. I don't know why I exported that. That probably should not have been exported. We do have a block table type in here, which is cool. Yeah, so I think I made pretty good progress today. I think getting all of this documented and just re-familiarizing myself with the code is probably a good idea before I actually, you know, sit down and do stuff with this. Oh wait, let me pull this out into a separate window. So yeah, I might make this a regular occurrence type deal. I'm very, very excited to see where I take this software. I think, especially by the time Notion releases their public API, I think my goal is to have this be the single Notion library you need for anything, regardless of your technical expertise. I want to keep like the web version of Chorale like alive, but I want to allow for more experimentation and more cool things to happen. You know. So so yeah, I am. I'm very, very, very excited to have more of this done and be able to release it and yeah, play around with it. All right, so thank you for hanging out with me on this live stream. I guess there's a few people that were on here. I think I have a few like single digit number of subscribers that might watch. But yeah, thank you so much. I really, really appreciate it. And yeah, I guess watch for one tomorrow or the day after. I don't know. I announce them on Twitter